So this is the last video for chapter 3 when we've been talking about the ways of presenting data, and we're just going to talk for a very short time about how we can compare two data sets, two or more data sets. When you're asked to compare data sets, you must always compare two things. You compare the location of them, and remember location is talking about things like the median or the mean. But then you must also compare how spread out they are, because two data sets could have the same measure of a central tendency, like a median or a mean, but one might be much more spread out than the other. And if you don't mention that, you're not communicating the differences between the data properly. So you must also compare the spread. So you might use something like the interquartile range, or you might use something like the standard deviation. Now, a word of warning. I've mentioned this in previous videos. It's really important that you understand. The median and the interquartile range go together because they're all calculated in a similar way. This is the 50th percentile. This uses the 75th and the 25th percentiles. However, the mean and the standard deviation go together, because if you remember from our standard deviation formula, it uses the mean x bar to work it out. It's a measure of how spread out the data is from the mean. So these two go together, whereas these two go together. What you must never do is use the mean with the interquartile range or the median with the standard deviation, because they're not related to each other. They worked out in a completely different way. So let's have a look at example 7. We're told that from a large data set, the daily mean temperature in August 2015 is recorded at two places, at Heathrow and at Leeming. So we have a set of data about Heathrow, and separately we have a set of data about Leeming for a certain number of days. So thinking about what the table might look like, you would have throughout August the temperature on the first day, two different values, the temperature on the second day, two different values, and so on. Now, some summary statistics are given to you. So for Heathrow, we're told the sum of x and we're told the sum of x squared. So we're given some really useful information there. So it doesn't matter that we don't know the individual values, that's fine. The other thing it's worth pointing out is that this is taken in August, which means we know that n is 31. Our sample size is 31 because there's 31 days in August. So first of all, we're asked to calculate the mean and the standard deviation for Heathrow. I'm going to use the letter x to represent the Heathrow data set. So the mean is x bar, and we know we find the mean by doing the sum of x divided by the sample size. So we have got 562.0 divided by 31. Let's write it down here because we always show our working out. Always, 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 always. And that's 18. Does it tell us how much, what degree of accuracy to give it to? No. So let's do it to three significant figures. 18.1 is the mean temperature. Now let's work out the standard deviation. Do you remember the formula for it? Take a moment, pause the video if you need to, write down the formula for standard deviation. So you should have the sum of x squared over n minus the mean squared, and then that's the variance, so we square root it to get the standard deviation. So we have got the sum of x squared, which is 10,301.2, n is 31. Now, for the mean, we must use this value. So you can either use the answer key, or you can write this calculation again and square it. What you mustn't do is just write 18.1 there, because the mean isn't 18.1, that's a rough value for the mean. I should have written 3SF there. Let's fill that in. And the square root thereof. So let's work this out. So we can do it all in one go on the calculator. The square root of, and then what, 10,301.2 over 31 minus the mean, which was roughly 18.1 squared. And that gives us, let's do it to three significant figures again, 1.91. You put our units on, write 3SF. Now think about what this tells us about the data for a moment. This tells us that the rough centre of the data is at 18.1 degrees, which strikes me as rather cold for August, but maybe it was a particularly cold summer. And each data value is the average spread of the data values away from 18.1 degrees was 1.91 degrees. So it doesn't mean they're all that far away. It means if you take all of the distances from them, then our way of the standard deviation, which is our way of calculating the average spread from this, is 1.91. Now, we are given the same data for Leeming. I'm going to use the letter Y to represent the Leeming data set because it's a different data set to this one, so it needs a different letter. Y bar, or the mean for Leeming, is 15.6 degrees, so quite a bit colder on average. And the spread there, it's a bit more spread out as well. 2.01 degrees is the standard deviation, which is the average spread from this mean. So, given this information, we are asked to compare Heathrow with Leeming. And the minute you see that word compare, you think alarm bells, two things, location and spread. But you must also write these in context. Context is king in statistics. You never just say the mean of this is this and the mean of this is this. You say the mean in the context. So we would write something like the mean daily temperature. And just by using the phrase daily temperature, we have put it in context. The mean daily temperature is higher for Heathrow, or you could say lower for Leeming, same thing. Mean daily temperature is higher in Heathrow. But then you look at the spread. The spread of temperatures is lower in Heathrow than it was in Leeming. So you could say, however, the spread in context, so don't just say spread, you say the spread of mean daily temperatures is smaller in Heathrow. Or you could say is bigger or greater in Leeming. So you've done the two things. You've talked about the location, you've talked about the spread, and you've talked about them in context by saying mean daily temperature, spread of mean daily temperature. I just want to point something out here with the wording on this. We worked out the mean of the mean daily temperatures. So if I'm being really, really strict, I should say that the mean daily temperature, because mean daily temperature is the thing that's being measured here. Let's make sure we understand what's going on there. What happens is, throughout the day, let's take day one, throughout the day there are lots of daily temperatures taken, and the mean of those is calculated and recorded in the large data set. Of all of those means, the mean temperature for day one, the mean temperature for day two, the mean temperature for day three, all the way through to day 31, we have worked out the mean of those. So the mean of the mean daily temperatures is higher in Heathrow, but the spread of the mean daily temperatures is smaller in Heathrow. So now you have done everything you need to do to access the mixed exercise. So you could have a go at that one.